Ferns are a type of pteridophytes, plants that have a vascular system like xylem and phloem, but plants that does not have seeds. So ferns are a type of them. So the pteridophytes that we know today are really small and they only occur in a narrow range of plants. But around 300 to 360 million years ago, these ferns dominated the entire earth. There were huge ferns up to 20 to 40-meter tall that made huge forest-like landscapes all across the earth. But there were one little problem. These ferns, when they fell, did not decompose fully. They just kind of laid there, pile over pile over pile. Now, why didn't these trees decompose? The problem was the wood of the ferns contained a special compound named lignin. The problem with lignin was it was something that was never seen before by the planet Earth. And the problem with that was the fungi there didn't know how to decompose lignin. So, when the ferns made up of lignin fell, the fungi didn't know how to decompose them. They fell on top of them for 60 million years. It was only then when fungi learned how to decompose lignin. And in this 60 million year period, the ferns fell on top of each other. Eventually, the sediments washed over the ferns, and due to pressure, these ferns formed into coal. That's why every coal that we know today is formed in this narrow period of between 300 and 360 million years ago, the period where trees didn't fully decompose. That's the only period where coal was formed. Now, in this period, the coal is basically carbon, and the carbon is from the trees that fell down, and the trees get carbon from carbon dioxide in the atmosphere. So, in short, the carbon dioxide in the atmosphere is being stored into coal underground in this period. So, essentially, the carbon dioxide content in the atmosphere decreased from 2000 parts per million to 200 parts per million in this period. And as coal was formed here, this period got the name Carboniferous period, meaning coal forming period. Now, in this time period, the carbon dioxide content in the atmosphere decreased, but the oxygen, the percentage of oxygen in the atmosphere increased because the oxygen isn't taken up enough by the other animals to offset the decrease in carbon dioxide. Now, this increase in oxygen percentage gave rise to huge prehistoric insects. And the reason is in the respiratory system of insects is really ineffective. The insects respire through tiny tubes called spiracles, and these tubes are super ineffective when it comes to providing oxygen. So the size of insects is limited because as insects get bigger, the spiracles will not be able to provide oxygen for them. But during that time, the oxygen percentage in the atmosphere was huge. There was a lot more oxygen in the atmosphere. Insects could get a lot more bigger. And because of that reason, dragonflies were the size of huge birds. Most insects were the size of dogs, and these prehistoric insects roamed the earth. The only thing that was clearing all these fallen up trees was the wildfires. There were periodic wildfires every now and then that sweep the entire planet. Because the carbon dioxide content decreased, the entire earth went into a period of global cooling. And right now, in the Anthropocene era, we are releasing that carbon dioxide back into the atmosphere by burning coal. The same carbon and the same coal that once caused global cooling is now causing global warming. Thanks for watching. Huge thanks to Trafalgar Nursery for helping me shoot in this. They have an incredible collection of ferns and various plants.